Hello, this video is going to show how we can achieve functional safety using HighTec development platform for TriCore and the Lauterbach TRACE32. Now the starting point is the HighTec development platform, and inside here I've created a number of projects for the TriCore, and this is the particular project I'm interested in, and it's a C++ program. Basically it's creating a linked list, a static linked list and a dynamic linked list, and then it's iterating 100 times and basically adding things to the list, removing things from the list. So first of all, let's check we can actually build this. So let's go and do a rebuild. I'll do a clean and I'll do a build, and there we can see that's building, and that's successfully built my executable. Now there's a number of things I'd like. First of all, I'd like to be able to look at my code and see, well, is it compliant to MISRA C++? Then I'd like to be able to look at the quality of this code and understand, well, is it too complex? And then finally, I'd like to be able to execute this code, and as it executes, I'd like to be able to find out, well, how much of that code have we actually exercised? Now, we won't get 100% coverage, and so I'll then use the unit testing tool in order to be able to complement that coverage. Now, let's start by analyzing the code. So what I'm going to do is I'm going to switch to the LDRA perspective, and now I can simply go and perform the static analysis. Well, I've previously analyzed this, so it should just refresh a number of documents and then it'll open up the report. So there we can see we have a number of violations against the MISRA C++ 2008. Class data is not explicitly private. Well, let's see where that occurs. And there we can see, well, that is public. Well, that's very easy to fix. Okay, what about the quality of this code? Well, let's go and take a look at a call graph. And a call graph, we can put it into a number of different modes. I could look at metrics that give me an idea of clarity, maintainability, testability. Well, let's take a look at the ones that give us an idea of maintainability. And here we're able to see all the functions. And if I expand this, we'll be able to see how they're interconnected. And we can measure metrics like the cyclomatic complexity. Well, let's take a look at this one, remove last. Let's view the flow graph. And the flow graph is giving us a graphical representation of the code. We can see here the code on the right, and if we click on a particular block, we can see the corresponding block on our flow graph. Similarly, if I was to click on a branch here, we can see this is the branch from here down to there. Now, what about executing this code? Well, let's go and do that. So I'm simply going to press this button, and this will now instrument the source code. It's then going to build it. It's then going to execute it, in this case using the Lauterbach TRACE32 simulator. It's now got the results back. We're analyzing those results, and we should be able to find that we've obtained pretty good coverage on this code. So there we can see the coverage we've obtained. There's lots of ways we can view this coverage. Let's start by looking at a report. So here we've got a dynamic overview report, and we can see very clearly we've got reasonable coverage, but there are some functions here for which we've got no coverage at all. Okay, well, what about at first? We can see we've got 85% statement coverage, and if we take a look here, we can see we haven't executed these lines of code here because the free node has never been equal to null. Well, I could use the unit testing tool tbrun in order to be able to complement the coverage and get 100% coverage for that static linked list. So let's go and invoke tbrun. Now inside tbrun, what I'm going to do is I'm going to open a sequence of test cases that I've previously created. So here I've got some test cases, and there I have the one for the static linked list. And if we click on this particular view here, we can see we have the inputs and outputs. So there aren't any for the destructor. There we have the constructor. So I'm checking the outputs, and then I'm using the object created by the constructor in order to be able to call all these other functions here. Right, well, let's go and execute this. So this is now going to generate a harness. It's going to build it. It's now executing it on the TRACE32 simulator. We're getting the results back, and we should now be able to see that our coverage should increase, and indeed we now have 100% statement coverage and 100% branch decision coverage for this static linked list.cp. So hopefully that's given you an idea of how we can work with the HighTec IDE and the Lauterbach TRACE32. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.